Alright everybody, welcome back. In this video we're going to discuss information from section 5 of unit 3 of AP Calculus, selecting procedures for calculating derivatives. Before we get to the main topic in this lesson though, there are two derivative rules that we haven't really talked about in any of the other sections that I find are handy for students to know. We certainly could use the derivative rules we already have for exponentials and logarithmics and some algebra in order to find these derivatives, but some students prefer to, use the algebra on the front end and know a rule and then just apply that rule when it's appropriate. So we're going to look at two rules. We're going to develop the rules for the derivative of a to the u, where a is any constant and u is any differentiable function of x, and the derivative of the base a logarithm of u, again, where a is any constant and u is any differentiable function of x. So let's develop our rule for the derivative of a to the u. The first thing you want to understand is you want to go back to thinking about rules that you knew for exponentials and natural logarithms. And one thing we know is that the natural exponential and the natural logarithm are inverses of one another. And therefore a, this expression a here, or this constant a here, can be written in a slightly different form for our purposes. We can write that as e to the natural logarithm of a. And that's equal to the same thing. And so a to the u can be rewritten as e to the natural logarithm of a raised to the u power. And then applying exponent rules, when I have something raised to a power and I raise that to a power, we're multiplying these exponents. And so a to the u is equal to e to the u times the natural logarithm of a. And we're going to use that relationship in order to help us find the derivative here, and derivative rules that we already know. So the derivative of a to the u is equal to the derivative of e to the u natural log of a. I sometimes just say e to the ulna. And then I take the derivative of this. So the derivative of e to some power is e to that same power times the derivative of the power. So in this case, the derivative of u times the natural log of a. Now something that's very important here for us to understand is that the natural logarithm of a, since a is a constant, that means the natural logarithm of a is a constant. And so when I take the derivative of u times the natural logarithm of a, kind of like when I take the derivative of 5 times x, the derivative of this is just going to be the constant multiple rule, times the derivative of our variable expression. And this derivative rule, of course, already has the chain rule baked into it. That's where the du dx is coming from. And now I'm just going to, return this e to the u log a back to its original form. We originally had it written as a to the u. And so the derivative of a to the u is a to the u times the natural logarithm of a times the derivative of u with respect to x. That's our chain rule that's showing up there. So there's a rule that we can apply anytime we see a derivative of some constant raised to a variable expression. So for instance, 2 to the x squared power. I can use this rule in order to find the derivative of that expression quickly and easily. All right, in order to develop the rule for the derivative of the base a logarithm of u, we're going to use a theorem that you should have learned in pre-calc called the change of base theorem, which basically says that whenever I have a logarithm to a particular base, I can change the base of this logarithm. And I'm going to change the base of this logarithm and use the natural logarithm, use e as the base. But anytime I have something like the base a logarithm of u, it can be written as some other base logarithm of the argument of the logarithm divided by that same base logarithm of the base of our original logarithm. So I could have rewritten base a log of u as I literally could have changed it to any base. I could have made it base 4 log of u over base 4 log of a. That wouldn't be terribly helpful for us here because we're trying to develop a rule for the base a logarithm of u, which is, these are still logarithms of that form. But the one logarithm that I already know how to take the derivative of is the natural logarithm, and that's why I use the change of base theorem to change it to that. And so then when I go to find the derivative of the base a logarithm of u, I'm going to rewrite the base a logarithm of u as a natural logarithm of u over the natural logarithm of a. And then I'm further going to split that down into the derivative of 1 over the natural log of a times the natural log of u. Now, again, since a is a constant, natural logarithm of a is a constant, so 1 over log of a is a constant. And so when I take the derivative of this, I can apply the constant multiple rule. I've got my constant multiple times the derivative of the natural logarithm of u. The derivative of the natural logarithm of u, using our rule that we learned for natural log, is 1 over u times the derivative of u. There's our chain rule application. And we can rewrite this into one neat, easy to remember rule that the derivative of the base a logarithm of u is 1 over u times the natural logarithm of a times du dx. Okay, so those are two rules to add to our tool belt. And it's kind of helpful now that we know these two. Think about all the derivative rules that we've learned in this course. We're now at the point where we have learned every single derivative rule that we are going to learn in our AP Calculus course. Are there some other more advanced derivative rules that you might learn later on in mathematics? Yes, there are a few, but we've got all these basic rules that we're learning for this course. So let's kind of jog our memory. And I think it would be a good time for you to go ahead and just pause the video here in the next few seconds and try and come up with your own list of, refresh your memory and think of all the derivative rules that you've learned and try and list them out here. So go ahead and pause the video, and after you're done trying to brainstorm your entire list of videos, come back and you'll see the list that I come up with. Okay? All right, welcome back, everybody. So, I'm going to try and kind of go from the beginning to here. The very first rule that we learned in this course, we learned the power rule for taking the derivative of functions of the form x to the n. And then the next set of rules that we learned are our basic algebraic rules. We learned the constant rule, and we learned the constant multiple rule. And we learned the sum rule and the difference rule. Okay, and after we learned those, we learned the more advanced algebraic rules in our next couple of lessons. Actually, before we learned the more advanced algebraic rules, we learned our trigonometric derivative rules. Just sine and cosine at that point in time. But then later on, we learned the rest. And we also learned our exponential and logarithmic rules. For e to the x and the natural log of x. And now today we added in a rule for a to the x and the base a logarithm of x. And then we learned our more advanced algebraic rules. We learned the product rule and the quotient rule. And that's where we came back and learned the rest of the trig rules. That was all in our last unit, Unit 2. And now in Unit 3, Let's see, we learned the chain rule. And we learned how to do implicit differentiation. Not really a rule, but just a technique for dealing with implicit differentiation. And then we learned, let's see, derivatives of inverse functions, how to find those. And then in our last section before this one, we learned how to take derivatives of inverse trig functions. So we have a pretty nice trigonometric. I always forget letters when I don't think about how to, like when I'm talking about something else when I spell trigonometric, derivatives of inverse trigonometric functions. So we've got quite a list of rules. These are all the rules that at this point in time and for, through the rest of this course, you want to be able to know and use these rules pretty much cold for the rest of the year. So if you're looking at this list and you're like unsure or uncertain about any of the rules for any of these functions, that tells you, it would be a good idea for you to review those rules. And I think that this is probably a good time to end our first video for this section. We'll come back and do a second video. Maybe even a third, hopefully just a second. I'm hoping we can get through everything in that one, but we'll see. And talking about how we're going to select, procedures as we go, we need to select from this entire list. And unlike as we've been teaching the different rules, when we were teaching them, we really focused just on one rule at a time or two rules at a time maybe. Now we're at the point where we know all these different rules and we never know when they're going to come up, so we need to think about how we're going to apply these rules in different contexts and different situations, and we'll talk about that next time. All right, everybody, have a great rest of your day. See you next time.